Okay, let's look at this question. We're gonna need to find a moment of inertia of this cross-section area with respect to the vertical centroidal axis, the vertical one, which is this axis. So to solve this question, we're gonna split the whole question into two parts. Part one is actually to locate the centroid of this cross-sectional area, the x bar and y bar coordinates. And then part two is we're going to use the parallel axis theorem to find the moment of inertia with respect to this vertical axis. So let's first divide the whole area into three small rectangles. First one is this one. Call it number one. Number two is the vertical one. And this one is number three. Okay, so let's go. Part one, centroid. Why do we need to find the centroid? Because the question asks about the vertical centroidal axis. So it's not about the regular x or y axis. It's about the vertical centroidal axis, aka y prime axis. And y prime axis is the vertical axis that passes through the centroid of this geometry. So we're gonna find x bar and y bar first. X bar for centroid has this formula: sum of x times area divided by sum of area, right? So we have, let's look at the first rectangle, the red one here. X is here, like somewhere in the middle here for this small triangle, which is gonna be 50, right? Because the total width is 100, so half of that, 50. And its area is going to be 30 by 100 plus the vertical one. Its width is 30, so half of that is going to be 15 times its area, 30 by 140. And the last one, it's somewhere here. The total width is 30 plus 170, 200 divided by 2, 100. Times its area is 200 by 30. Over the total area, which is just this plus this times that, plus this times that, plus this times that. And x bar gives me 61.6 millimeter measured horizontally from the origin. Similarly, we're going to do y bar is equal to sum of y times area over sum of area. So for y bar, let's go from top to bottom again. The red rectangle, the first one, y bar is the distance from the origin all the way to half of its width. So we got 30 plus 140 plus another 30 divided by 2. uh, multiplied by its area. Oh, whoa, what is this? It was at 30 plus 30 plus 140 plus 15 multiplied by its area, which is 30 by 100. And then the middle one, we have 30 plus half of 140 plus multiplied by its area, which is 30 by 140. And the last one, we have half of 30 multiplied by its area, 30 times 200. Everything, add them up over area. Let me double check. Yeah, and this I get 80.7 millimeter measured vertically from the origin. Now we can do the moment of inertia. So we're gonna do the first rectangle. What is the moment of inertia with respect to y prime? Do the second rectangle, do the third rectangle, add them up. The formula is like this. We're looking for y prime, right? I y prime is equal to IC plus a d squared. Iy prime is moment of inertia with respect to the y-axis, y prime axis. This is the axis of interest. IC is the moment of inertia that passes through its own centroid, right? There is a ton of axes that pass through this single centroid. However, we're gonna choose the one that is parallel to y prime. Let's say y prime is here. This two must be parallel so that we can find a vertical distance. Well, not just vertical, but the distance between them. If these two axes, they are not parallel, then there's no distance. Distance is not uniform. We can't find a fixed value for distance. So these two must be parallel to each other. This is D. D stands for distance, and A is the area of this shape. The addition of AD squared is called parallel axis theorem. So this is parallel theorem, parallel axis theorem. It's like if you want to find what is the moment of inertia of this area about another axis, then first step you're gonna find what is the moment of inertia of this object with respect to its own centroid axis. Find that axis, find the distance between these two axes, make sure they're parallel, and then you add AD squared. That's it. I'm gonna put this on the side. Now, since the geometry we're dealing dealing with are rectangles. So for rectangles, the centroidal axis, this moment of inertia for a rectangle with respect to its centroid is 1 over 12 bh cubed. Now the question, what is b and what is h? Let's draw a rectangle here. Since the question is asking for the vertical axis, let's say the vertical axis, this is our y prime, right? Let's do this as example. B is the side that is parallel to the axis of interest. So this is B. And the side that is perpendicular is H, right? And the distance, the AD square, the distance is this. And this is a horizontal distance. So we're gonna need X bar, right? To figure out that distance. Remember, for a rectangle, B is the side that's parallel to the axis. H is perpendicular to it. We're gonna cube H, not B. And it can vary, right? If the axis is here, then this becomes B. This becomes H, right? But in this case, y prime axis is vertical, so let's use that. Plus AD squared. Now, what is D? Let's figure out D first. For the first rectangle, we know that our centroid is here and its horizontal distance, this is X bar. And the centroid of this is clearly shorter than X bar, so we can use X bar minus half of the width of this rectangle to get the distance, because basically what we're doing is let me use green. There is this dot that represents the centroid of this rectangle, and we have a parallel axis that's passing through it. This is its IC for this rectangle, and we also have the X bar, which is here to here. This is X bar. We can calculate this distance so that we can know what is this distance. This is our D. So we're going to use X bar minus half of the width of this rectangle. If you don't know how to do this distance in exam, just do a little sketch and figure it out easily. So the width of this is 100, and rectangle, well, we know it's going to be half of it, so 50. So X bar minus 50, that's my D. X bar was where it's 61.6, so I got 11.6 for my D. Now, B and H, don't make mistake here. This is a really silly mistake to make. Again, Y prime axis is vertical. So what's vertical? It's B. That's 30. H is the horizontal one. In this case, 100. Cubit plus area, 30 by 100, and the distance square. Use a calculator, I got this value. Unit is millimeter, or whatever length, to the power of 4, because we have basically everything millimeter to the cube of 4. So B is millimeter, H was millimeter to the 3, right? Because we cube it, and you time this 2, we got millimeter to the power of 4. The other part of the equation, AD squared, A already has millimeter square because it's area. D was length, millimeter, and then you square it, become square it, and then you time this 2, we got millimeter to the power of 4. So the unit of moment of inertia is whatever the length you're using, kilometer, light year, nanometer, whatever you want, to the power of 4. Second rectangle, the vertical one. Again, this is very systematic. Just write the equation, guide yourself using the equation, figure out what's what. That's it. Instead of writing A, you can also write BH, but we all know for a rectangle, A is BH. Figure out what's D first. It's going to be X bar minus, because half of distance is here, right? I'm going to say X bar minus half of 30. So this is going to be 46.6. 4.6. What's B? Vertical is B, so 140 is B. What is H? H is 30 cube plus 140 times 30 times 46.6 square. You got 943,555.2. millimeter to the power of 4. Okay, and then we have the last rectangle. Same thing. Iy prime is equal to IC plus AD square 1 over 12 BH cube times plus BH times D square. What is D? We know D is half of this length, right? That's gonna be 100. And then since 100 is more than X bar, so we're gonna use 100 minus X bar. It doesn't matter because we're gonna square it. You got a positive value anyway. What is B? What is H? Vertical axis or vertical side is B. 30 is B. And the horizontal one is 200. And in the end, the total, we're gonna say total Iy prime is Iy prime, like, 1 plus 2 plus 3, which is gonna be the sum of all these three, very big number. And this is it for this question. Okay, for this question, very similar thing. We're gonna find a moment of inertia of this shape, beam, whatever it is. And one more step after we find a moment of inertia, we're gonna find the radius of gyration about x-axis. So everything is with respect to Mr. X-axis. Okay, so well, since the centroid is already given, it is this dot A. So how about we gonna label the rectangles? So this is 1, middle one is 2, and bottom one is 3. Okay, so let's just find a moment of inertia of each rectangles, add them up. With respect to x-axis, so we're gonna need to use the parallel axis theorem again. I'm gonna do this. IC. Now, what is D for the red rectangle? First of all, question asks about x-axis, horizontal one. So it's actually y bar, because the vertical distance here, this is y bar. Not y bar, but like, you get what I mean. Vertical distance between two horizontal axis. So that's gonna be 24. Plus half of 6. That's for D. So we have 1/12 times B again. In this case, axis of interest is horizontal. So parallel to it is B. Horizontal side is B. That's going to be 2 times 12, 24. Vertical one, perpendicular one is H, cube that. This gives me 105.408. And number 2, we have the same thing. Ix is equal to I centroid plus parallel axis theorem. D is gonna be 0 because they overlap. So there's no AD squared. It's simply 1/12 BH cube. B is horizontal 1, 8. H is gonna be 2 times 24. Cube it. Half of the width, distance here, this is D. So 24 plus 6 divided by 2, 27. And now we're going to add them up. The total is going to be 389952. And now, question is not done yet. We have one more thing to figure out. What is the radius of gyration? And in this case, about x-axis. So that is kx is equal to the square root of ix over total area A. Right? So we have total area. Did we calculate that before? No. Never. So 48 times 6. No. Top one is 12 times 2 times 6. 24 times 6. Plus 8 times 48. Bottom one, 6 times 48. Root this thing. We have 21.86 millimeter. That's it for this question. Very easy one.